morning. So today we're going to speak about our paper, Cost of Security of Layer 2 Network, Evidence from Polygon Network. My name is Nir Chemaya. It's a joint work with Kite that is here. Both of us from UCSB. So before, let's a little bit speak about the idea about the DeFi seminar. So it's the second year that we're running this seminar. It will take place virtually over Zoom on Fridays at 9:30 a.m. Pacific time. The idea is that we want to also allow people from Europe to join us. So that's why it's early. It's going to be open to everyone, so feel free to share and invite people. We want to build a community for researchers that are interested in DeFi, crypto, blockchain, but more econ related. So we want to allow people to discuss about the economics and less about the technical aspect, but more about the economics, because we think that there is a lot of discussion about technical aspect. Computer science are leading this environment, but we want to put more focus to the economics. So feel free to share the website with everyone. This is the code for the seminar website and for the Discord. Questions, something? Okay. So now let's speak about our paper. So let me a little bit give some motivation. So we know that the use of decentralized exchange platform has been growing in the last few years. It's mainly because of the big interest in decentralized finance, DeFi. And most of these DEX platforms work on Ethereum blockchain, also known as L1, layer 1. But layer 1 has some problems with scalability. So layer 2 solutions, blockchain recent innovation, now provide better scalability and lower gas fee compared to Ethereum blockchain. So some protocols like Uniswap have started to support L2 blockchains, such as Polygon. And our first question was, how do agents decide which network to use when they trade? So the idea is now that people can choose between L1 and L2, how are they going to make the decision which network to use? But like if we think about the economics, if you have two options where to trade, one you pay low gas fee and the other you pay higher gas fee. So the first intuition, everyone going to switch to L2. But there are no free meals. So there is kind of a trade-off between networks that give you high scalability and lower gas fee with security and decentralization. And this trade-off is also known as the blockchain trilemma. So, however, the security of L2 relative to L1 is unclear and hard to identify. I will explain later why. So our second idea, and it's kind of the main of the topic, was, can we estimate traders' beliefs about these security aspects from trading data from DEX platform? And we're going to use Uniswap. Okay, so again, just to a little bit explain more about the blockchain trilemma. So the trilemma came from Vitalik, that mentioned that it's really hard to create a decentralized blockchain that's going to be fully decentralized, very secure, and with high scalability. It's really difficult to create an environment that's going to have all of them. And the reason why is because if you want to have a security in the validation process, so you're going to end up with doing a validation process that's going to take time to make the validation, and this is going to reduce scalability. So there is like kind of a built-in problem of creating something that's going to have all these features. Let's little bit give some intuition about the scalability problem. So blockchain networks that are very decentralized and secure, like Ethereum, can handle right now around 30 transactions per second. So for comparison, Visa, for example, can deal with 65K transaction per second. So there is a big difference, okay? Layer 2 solutions like Polygon give a little bit better scalability, and it's going to be around 10,000 transactions per second, so it's much higher than Ethereum. And the second point that it's really important is that when you have a network like Ethereum and Bitcoin that can deal with low amount of transaction per second, and it's create a network contingents, and it will going to make that the gas fee will be really expensive. Why? Because a lot of people compete on executing a transaction while the supply is really low, so the gas price goes up. If someone wants to ask a question, feel free. So before going to our research question, first we took a data from two pools with the same tokens, with the same liquidity providers fees. Like we try to compare apples to apples, but one on Ethereum blockchain and the other on Polygon. And the idea is we want first to see how the distribution of transaction looks. So you can see that we have here the counting how many transactions we're going to have and the size of the transaction. All the transactions that are 10,000 and above, and everything is in US dollars units. So we put we gather them together. So you can see that in the Ethereum, most of the transactions are greater than $10,000. So it's a lot of money, big transactions. And the rest is really small, okay, relative. While in Polygon, we have a really different way, really different distribution, okay? The distribution is that very small, big transactions, and the majority of the transactions are really low, okay? So this is like the basic observation that make us think about our product. So our research questions are, first, if L2 has higher scalability, a lot of transactions can be made in seconds and with really low fee, few cents relative to L1 that is Ethereum that can be up to $100. So if the traders can use a place that they can pay only a few cents for trading, why not everyone shifting to L2? And we can see from the data that we still have a lot of people using Ethereum, especially in high transactions. So the second question is, why do transactions split in the way as figure 2? So why we have a big transaction on Ethereum and small transaction on Polygon? So one argument going to be that there is more liquidity in Ethereum pools, which make it be more profitable to trader in big transactions due to the liquidity pool pricing mechanism, which I will explain later. But we find that it's not explain all the gap. So the second aspect could be security, and this is what we're going to address in this paper, okay? Question? Cool. Okay, so let's a little bit explain what is liquidity pools. That is one way of providing decentralized exchanges. So liquidity pools are a new innovation in decentralized finance that allow investors to exchange crypto assets without the traditional centralized limit order book mechanism that Coinbase and other centralized exchange platforms use. Investors deposit tokenized assets into a smart contract. Okay, so you can think about it that liquidity pool is basically a smart contract. And then traders can exchange token from these pools according to the terms prescribed by a mechanism that determines each transaction swapping price. So there is a swapping price mechanism that is basically a code that explains how, like, that actually determines how the price going to be determined. And most of these pools using a bonding curve pricing rule that is also known as the CPMM, and I will go more and explain about it later. In order to incentivize agents to provide liquidity, so for each swapping transaction, traders pay fee, and this fee can be between 0.01% to 1%. The most platforms are Uniswap, SushiSwap, Balancer, and Bancor. We're going to use in this paper and in our data Uniswap, that is the biggest. Most of these protocols works on Ethereum, on L1. And in March 28, 22, the daily volume on Uniswap was around 2 billion, and the total liquidity was around 5. So a lot of volume, a lot of liquidity. And again, in the last few months, some liquidity pools like Uniswap have started to support layer 2 network, such Polygon, Optimism, and Arbitrum. In our paper, we will focus on Polygon. So we're going to have L1, it's going to be Ethereum, and L2 is Polygon. So even that all this decentralized exchange environment is new, there is really nice and interesting works that first, some of them compare between centralized exchange platform and DEX platform, okay? And this is in order to give some to shed some light about price efficiency, transaction cost, and more, to compare between the two options that traders can trade, centralized and decentralized. Some papers went a little bit more about the pricing mechanism, the CPMM, and discussed the benefits and problems of using this mechanism. And again, we went in another direction. We want to focus on if we can use trading data to elicit traders' beliefs about security and say something about the security aspect. So given that we are going to deal with security, let me mention few of the risks of using of trading in a decentralized exchange platform. So first risk is what we call bugging risk by using a smart contract. So smart contract is basically a code. And if you're going to use this code, so any bug that you're going to have in the code, going to put in risk your assets. So this is one risk. Another risk of using smart contracts can be admin keys. So each smart contract could have admin keys who can access the code and modify it. And it can create two problems. First, someone can hack to the admin keys and change the code. And then if I use the smart contract, they can manipulate it. Second, if there is admin keys for some people, they can manipulate the code because their own interests, and it also can create a centralization problem. So one example was a $34 million that there was a bug in the code of the Aku Dreams smart contract, and basically no one now can withdraw the money because there is an error in the code, and there is no access to the money. So the users that use this smart contract lost their money. Second risk is what we call war-up token risk. So the idea is that if you have Ethereum token on Ethereum, so it's a native token of the network, so you can use it in Ethereum, everything is okay. But once you want to move it to another blockchain network, let's say Polygon, you need to use a synthetic that's going to represent your holding in Ethereum. This is what we call war-up tokens. And in that case, if the way that you're going to move your asset to the other network, which is going to involve what we call bridge, if there is any problem with the bridging mechanism, so you have some risk about this Ethereum token, so it could be that you hold the Ethereum tokens on Polygon network that you going to have a problem to withdraw them back in Ethereum. And so one example for this risk is the Ronin network hack. So Ronin network is a gaming network, gaming blockchain, which in order to get tokens in Ronin network, you need to use a bridge. So you deposit assets on the Ethereum blockchain, and then you can get tokens on Ronin. Someone hacked, stole money from the bridge mechanism of this network, and it's had like 600 million lost for the user. And the last point is what we call the validation risk. So each blockchain network using a different validation mechanism, and the idea that most of this mechanism works on consensus and agreement. So if one of the validators is going to have enough power, then that's why we call this also a 51% attack. So if you're going to have enough power to have the majority, it can manipulate the validation process and then do a double spending attack or whatever. So one example is the Bitcoin gold blockchain that they had a 51% attack at May 18. Now let's go to the problem of comparing between L1 and L2. So one of the problem of comparing between L1 and L2 is that each blockchain uses a different validation process. So for example, Ethereum used to be proof of work system. They recently moved to proof of stake. But their validation mechanism is really different from Polygon, for example, because Polygon are doing proof of stake, but with a different permission to which users can be validators. So there is a difference in, let's say, centralization of the validation process, and also the validation process itself is different. And so it's the bottom line is that L2 solution use a different validation process than L1, and therefore it's hard to tell how much they are riskier than L1, if at all. Okay, so given all this, we prefer to go in another direction and went more about eliciting people believes about these security concerns from the data. Questions? Okay, perfect. So now let's go to our model. So before introducing our model, let me a little bit cover the constant product market maker mechanism, which is the pricing mechanism that most of the liquidity pools use. So the idea is that it's really simple. The pricing rule is that XT, the amount of token X multiplied by the amount of token Y must be equal to a constant number K. So this ratio must always be the same. So first we can express like the exchange rate between the tokens in any given moment by the ratio between the amount of token X that I have to the amount of token Y. So think about it, if let's say one Ethereum costs $100, so I'm going to have in the pool one Ethereum token and $100 token. Okay, so this is the exchange, right? Now, how the swapping price determinate for the next transaction. So first, we have F going to be the protocol swapping fee. Again, it can be between 0.01% to 1%. And for each transaction that I need to pay this fee for the liquidity providers. So what left for me to trade is 1 minus F. And then if in time t+1 I want to trade, and let's say, for example, I want to swap Ethereum tokens that in this case going to be token type X to Bitcoin tokens that in this case going to be type Y. So I'm going to give delta X, delta tokens Ethereum, and I can calculate by this pricing rule mechanism how much Bitcoins I'm going to get, okay? And this is going to be delta Y. So I'm just going to use this formula. So we have K as the constant number. So this is going to be the amount of tokens that I'm going to add to the pool as Ethereum tokens. And then I need to withdraw this amount of Y tokens, but it must be that what I'm going to get out will maintain this ratio. So then I can solve and I can calculate how much tokens Y I'm going to get. And by doing this, I also can calculate how much was for the trader, what was for the trader, the exchange rate. So this how many tokens he gave and how many tokens he got. Questions? This is the basic, and from here we go to our. Okay, so just something that is important, we can see here that for each transaction, the price is going to be determined by 3 important facts. First is the transaction size that I'm going to do, and YT and XT that going to be the liquidity of the tokens X and Y in the pool. So the most important facts that we need to take from this pricing rule mechanism is first that this formula convexity relation implies that once trader have more demand for token X relative to token Y, the supply of this token in the pool will decrease. So its swapping price will increase. Okay, so the basic idea is the demand that once there is more demand to Ethereum, for example, and you have a pool with Ethereum and Bitcoin, so more demand to Ethereum will create a situation that the price of Ethereum relative to Bitcoin will go up and up. Second point is, given this pricing rule mechanism, large transactions have a large price impact. So you can think about it, if I have a pool and I'm going to trade 1 Ethereum token, so I am going to have a really small price impact on the pool. But if I want to do a 1,000 transaction, it's going to have a greater price impact. And this price impact also depends on the pool liquidity. So when we have a lot of liquidity in the pool, even big transaction can have a really small impact because everything is relative to the pool size. Okay, so if we go back to this formula, your transaction and the pool size, that is Y and X, and those going to influence your exchange rate. Okay, now we go to our model, finally. So the idea of the model is we use a representative agent maximization problem. So trader wake up in the morning, you want to trade delta X tokens. And given this this amount that you want to trade, the only decision is if I want to use Ethereum network or Polygon. Each network going to have different security parameters. So security in our case, it's a parameter between 0 to 1, which one is fully secure. And you can think about it as the probability of losing your transaction. Okay, so for example, if it's 1, it means that your transaction going to be successful and you're going to make the swapping for sure. Every number that's going to be below 1 means that with some probability that is going to be 1 minus pi 1, you can lose your transaction and all your money go out, or go to someone that's going to manipulate you for a thief or whatever. The second parameter that we're going to have is the price impact. So you're going to use the pool. We know that the pool exchange rate can change depend on the pool side, on the liquidity on the pool. So every time that you want to make a transaction, you're going to have a different price impact if you use in Ethereum or in Polygon. And finally, we have gas fee, how much you're going to pay to the miners, to the validators, and this change. So again, in Ethereum, it can be up to $100 for swapping. And in Polygon, it's almost always few cents, so it's really cheap. So the trade-off is between Ethereum and Polygon. And the intuition is that given that you pay really low fee in Polygon, it's really cheap. So you want to trade in Polygon, but the price impact on Polygon is not very good in big transactions. So there's going to be a switching point that if your transaction is big enough, you want to switch to Ethereum. Okay, questions? Okay, so we're going to assume risk neutrality. It's fair assumption because we deal with crypto markets, and most of the guys that trade in crypto market are risk-seeking, I will say. So risk neutrality is fair assumption, and also we know that traders want to maximize their expected payoff. Now we can plug in back to this model Ethereum and Polygon as the networks. So 0 and 1 going to be Polygon and Ethereum. Okay. And now we want to find, as I mentioned, the indifferent point, which you are indifferent between trading on Ethereum and Polygon based on all the parameters that we observe. We can observe the liquidity in the pool, so the pool size. We can observe the gas price in any given moment. And then we're going to calculate the switching point. And we're going to, just for simplicity of the notation, we're going to call it W. So W going to be the transaction size, the switching point, when you are indifferent between trading on Polygon and Ethereum. And again, the switching point is in a way that any transaction below, it's more profitable to trade on Polygon. And any transaction that's going to be above, it's going to be more profitable to trade on Ethereum. Now, this is also include the behavioral parameter of people's beliefs about security. Okay, Pi Ether and Pi Poly, it's the security parameter. T going to be the network fee that they pay for the miners, and P going to be the price impact, the exchange rate that they get in each network. So this is going to be the things in the formula, in equation. What we are going to do now is we're going to use something that we call monetary optimal switching point, which is equation 2. And the idea is that we want to put a little bit aside all the security aspect, to ignore it. And let's say that the security is perfect and is one in both networks. So we just want to speak about the monetary value. And then we can calculate W star going to be the monetary switching point. So without any security concern, which network going to give me a better return, and I'm going to have a switching point that will be optimal for me. Later, Kite will introduce you how we observe W from the data. And by observing W from the data, we can compare the difference between W from the data to the W star and say something about these security parameters. Any questions? Okay, so I guess Kite, it's your turn.
Okay, so before we get started on that, let's just confirm two things. We say that Ethereum has higher gas fee than Polygon. So this is what we have. We collect the data from December 2021 to June 2022. We have 6 months of data. Here we can see the gas fee of Ethereum fluctuates, but it's always well above Polygon. You may even notice that the y-axis, it's a little distorted, that because if we don't do that, the Polygon line would look like exactly like a straight line. There's no fluctuations at all. Well, there is actually some fluctuations for Polygon's gas fee too. It's just compared to Ethereum, it's basically nothing. The mean gas fee in this period for Ethereum, it's about $47. And the mean gas fee of this period for Polygon is only 14 cents. So it's a very huge difference on the gas fee.
Why does
and then the other
so much more on Ethereum?
Why is it so much
why
more
does
expensive
it
on Ethereum?
Yeah, why does it fluctuate so much more than Polygon?
So the gas fee really depends on how busy or how the congestion is, and the more usage of it will drive the gas fee up. And the fluctuations mainly come from the popularity of the market.
Got it. Thanks.
This data is at a daily level, by the way. All right, so the second thing we want to confirm is we say, okay, maybe people want to trade on layer one because layer one has more liquidity. And is that true? There, can we go to the next slide? Thank you. So here is the pool size of the 6 months during our study. And for the average pool size during the 6 months period, Ethereum is $22.6 million. And well, for the same tokens Polygon pool, we got the average pool size about 6.7 million. So it does seems to be like Ethereum does always have a larger pool size than Polygon. So that could be the reason why people are want to trade on layer one Polygon. But as we have previously explained, let's go to the next slide. So we previously explained that imagine you have a very small transactions, then you're not making many impact on the pool. You're not making many impact on the price. So you're probably getting similar price on both platforms. It doesn't really matter what the pool size is because your transaction is small enough that the pool size doesn't really matter. Then when you consider where to trade, the driving force will be the gas fee. So here in the graph, on the main graph is on the right hand side. What we draw on the x-axis is the swapping value, the value that you put in for swap, and the y-axis is how much value you're left out of the swap. Okay, so let's zoom all the way in to the very left of this x-axis. What we have is these very small valued transactions. You don't really have impacts on the pool. So what's happening is then, okay, because now if you trade on Ethereum, there's a really high gas fee. We're talking about like $50, even $100. So then that will be the driving force. So what we have here is the yellow line, which is the Polygon, will always give you better value left than Ethereum. But once your trading size got larger and larger, once we reach to the right hand side of the graph, once you're trading $1 million transactions, that's actually gonna impact the pool, because your transaction size relatively the pool size, it's not gonna be ignorable. Okay, so eventually you will see the blue line will be above the yellow line, which makes sense because if you're having a really huge transactions, then the gas fee $50 is no longer very relevant to you, but the impact on the price that you're getting from the pool is more important. So these two are all increasing functions. We know at the very left hand side yellow line was above blue line, and then on the very right hand side blue line, eventually it's going to be high above yellow line. So there must be a single cross point that we can see the yellow line exactly intersect with the blue line. For this day, January 10th, 2022, it's an arbitrary day we picked. That intersection point, it's about 27,700. And give you some more background information about January 10th. The gas fee that day for Ethereum, it's about $110, and for Polygon, it's something like 20 cents. And the pool size, it's about, Ethereum is about 40 million, and then Polygon is about 10 million. So given all these conditions, we can actually find where does that intersection happens for the blue line and the yellow line, which will be at this exact swapping value, you will be in difference monetarily to trade on L1 or L2. And for this day, I like I was saying, it was about 27,800 something. So we do this for every single day in our 6 months period, and this is what we got. So this is what we got. So for each day, we calculated, we input what's the pool size of Ethereum and of Polygon. We asked what's the gas fee, and then we asked, okay, what's the value that people should be in difference trading on both platforms? And then we say this is the monetary optimal switching point, W star, because at this point, people shouldn't be, people should be in difference trading on both ones. Then if anything below this threshold, people should trade on Polygon. Anything above this threshold, people should choose to trade on Ethereum. All right, so that's what we say from the model. This is what we expect people to behave. But is this really people behave in real life? Do we observe this in real life data? Do we observe this as people's trading patterns? So we want to go to the empirical data, and then we want to ask the same question. The question is, where do people switch from trading on Polygon to trading on Ethereum? All right. So in order to do that, we perform a we implement a binary logistic model. So here we our representative agents empirical thresholds. We assume let's say the probability of y equals to 1 here is the probability of the trader is going to trade on Polygon given their trading size equals to this equations, and the logic of it will be follow a linear patterns in W. All right, so we also consider LDA. However, LDA you have to meet certain assumptions, but the assumptions are not really easy to make here with our data set. Let's see an example table that we get from this regression. And so this is what we have. We run the logic regression, and then as you see for here, the transaction value has a, the parameter is negative, which makes sense because if you think about the larger transaction value you have, the less likely you should be trade on Polygon. And that's why that parameter is negative. All right, okay. So what we do here is then we run the logistic regression. We get this table, and then we go let's go back. And then let's go to the next slide. What we have here is that one then can predict the class, whether the transaction is going to be on Polygon or it's going to be on Ethereum by thresholding the predict probability. You can think about if you want to do very conservative on whether the trade is on Polygon, then you can say, okay, if and only if the probability, the predicted probability is 100%, right? Then I'm going to say, okay, I'm going to categorize this specific transactions to be on Polygon. Or people could use 50%. Let's say anything the predicted probability is greater than 50%, we categorize it as Polygon. Less than 50%, let's categorize it as Ethereum. So it's kind of like arbitrary point. But by constructing a confusion matrix, and we can actually bring down the threshold probability that give us both a false positive rate and a low false negative rate, then we can obtain the best threshold probability on the performance of the on the performance. So what that gives us is this threshold probability, let's call it probability hat. So then we can actually calculate it, the empirical threshold value W hat in this written form, where beta 0 and beta 1 hat are obtained from the logic regression. Right? So let's see what we find in the next slide. So again, just as an idea for you, in January 10th data, we have the threshold about 94% for predicting power. All right, here. So what we plot is for each day, again, we are going to go into the empirical data, and then we're trying to figure out where do people switch from trading on Polygon to trading on Ethereum. And this is what we got. It might not be very obvious, but there is actually a shaded area around this blue line. That's the 95% confidence interval obtained by Bootstrap. It's very close to the confidence interval. It's very narrow. All right, so at this point, you would want to see a graph that actually put the red line in the previous W star graph and the blue line here of the W hat star into one graph. So that's what we did. And this is what it looks like when we have both W in the same graph. We do take the log of the transaction value to make it a little bit easier to read. So here, what we have, it's the red line is the monetary optimal switching point, and the blue line is what we actually observe people do. You can see in this 6 months, it's very consistent. There is a consistent gap that between these red lines and blue line, between what we think people should switch, which maximize their monetary payoff, and what they actually do, which is the blue. The intuition is as follows, is that due to security concerns, people now want to switch to Ethereum earlier from Polygon, trading from Polygon. Thus, we see the gap. You see that like the blue line is always below red lines. People are always switching early than what we expect them to do if they want to maximize their monetary payoff. Okay, so then how do we explain this gap? And our answer is the security concern is the reason that we want to explain this gap. So if we go to the next slide, what we have is the security concern explains this gap between the switching points. Recall that we say pi I in our model is traders' belief on the probability of not losing one's transaction walls in network I. Then when we consider the ratio of pi, when we say like the pi poly over pi ether, it should be smaller than 1. You know, as the probability of not losing one's transaction walls in Ethereum network should always be greater than on Polygon network, okay? Because Polygon network is layer 2 and then building on layer 1. And then our calculation actually confirms this ratio to be always smaller than 1. So in this graph, we plotted out what these pi ratio is. And here we see it's very consistently below 1, that is pi poly over pi ether. We did also use Bootstrap to construct 95% confidence interval. None of the confidence interval actually cross the ratio of 1, so it's always below 1. On average, trader anticipated 1.93% more chance of losing their transactions when trading on L2 than trading on L1. All right, so this is the graph we obtained for the 6 months. It's very consistent below 1. It's always around in the graph. It's always around 97, 98%. And then if we consider that as what's the chance of losing the transaction instead of not losing the transaction, which is the 97%, then we convert that into like a 1.93% chance of people's belief on they might lose the transactions. Okay, so let's put things in summary. These new layer 2 blockchains alternative provide better scalabilities and lower fees than the Ethereum blockchains. But the security of layer 2 relative to layer 1, it's unclear and difficult to identify. So what we do is we use a structure model and a novel and comprehensive data set, and we try to find traders' belief on these security issues. And then we found 1.93% chance of losing the transactions. This is very considerable amount. It compares to like only the 0.3% transaction fee charge on these two specific pools that we choose. Our work can be seen as an empirical evidence of the trade-off between scalability, security, and decentralizations. The trilemma, the biggest challenge of the blockchain network. So we also developed some insights on the impact of layer 2 networks, solutions to the inclusion of DEX, because we do observe that layer 2 solutions such as Polygon allow traders with low stakes to enter the market with a low network fee environment. We do observe a lot of transactions on layer 2 than compares to on layer 1, while still being very small size transaction. It's not like after layer 2 is provided, then people who trade on layer 1 move to trade in layer 2, but we do observe a lot more new traders starts to trade in layer 2 network with these small size transactions. All right. Okay, so that's all. Let's see. I see some questions in the chat. Let me open that. This one. Nir, do you want to answer the questions, or do you want to? I think maybe you're muted.
Yeah.
Okay.
Yeah. Good question. So, using bridge is costly. So you need to. The problem with using bridge is that you need to pay both gas fee on Ethereum and on Polygon, because you need to have a transaction on Ethereum when you deposit your Ethereum tokens on Ethereum, and then what's happened, you're going to get the tokens on Polygon, so also someone going to charge you for the transaction or on Polygon. But in Polygon it's few cents, so it's costly. But the idea is that the way I'm thinking about it is you can imagine that you have a saving account and checking account. So I think most of the traders, what they do, they have a lot of assets on Ethereum, then they allocate some budget to trade on Polygon. So they do only one. They have only one bridging cost to allocate funds to trade on Polygon, and then they do as much as transaction they want in Polygon, and whenever they want, they can always go back.